Hello everyone and welcome to solutions video for Codeforces Educational Round 121. Yep, the server went down midway after around 1 hour and 8 minutes. So most probably it will be unrated, but you should absolve because that's how you improve. But before jumping into the solutions, let me remind you to join my Discord server because I will be using it for videos in the future, also for random discussions. Might as well join. Let's be real, you don't have anything better to do. That being said, let's discuss the solutions. So in the first problem, we have a string which have characters, the lowercase Latin letters from A to Z. It can have one of them, some of them, and every character is present at maximum twice, I think. No, exactly twice. So every character appears exactly twice. So a string can be like something like this. Now what we want to do is we want to rearrange this such that the distance between the two characters A, let's say if this is X, then the distance between the two characters B should also be X, and for C should also be X, and so on. So what if X was 1? Then everything would be adjacent, right? So if we just sort it, we will get what we want. So that is one solution. We can just sort the string. Now I'm not able to access my solutions, but obviously the solution for this will be extremely simple. You just take a string as input, you sort it. Okay, wait, let me zoom in. You sort it and then you print it. This is solution for A. All right, let's move to problem B. So what was problem B, huh? So problem B was also, okay, it was not very simple, but it was fairly simple. So we have a number which is very big. It can be of length 2e5. So it is basically a string. So let's say we have a number 6322001. This is our number, and what we can do is we have to do one of the operation. We must do this operation, okay? And what that operation is, we pick two adjacent numbers. Let's say we pick these and then we add them. So 7 plus 6 is 13, and all this we just write as it is, and all this we write as it is. So 9005 and then 322001. So we want to say that after doing this operation, what would be the maximum possible number we can get. So let's observe this operation first before jumping to any conclusions. Okay, so what was this? 63, I guess. Does it really matter? So after we do this operation, two digits gets added, and when two digits get added, so let's say 5 and 0 get added, we get 5, and if 7 plus 5 gets added, we get 12. Notice that sometimes we get a single digit number in for replacement of two digits, and sometimes we get two digit number in replacement. And if we get a single digit number, that means the total number of digits decreases. And let's say we have some number like 99999. This is always less than a number that has one more digit than it, right? The next number to it will have more digits. I mean, not necessarily, but any number that has more digits is obviously greater. So we want to prioritize this type of operation. So we can be able to do this operation at multiple places. So which one do we choose is the question. Okay, this looks like theta. Let me just make it 0. So here, notice that we can do it at 7 and 5. This is number 1. We can do it at 7 and 6. This is number 2. And if we do it here, we get 12. And if we do it at 7 and 6, we get 13. But at different places. So which one is better? Well, you can try to do some try and error, and you will realize that the one that is on the right is always better. But the logical way to approach that is that notice that whenever we add two digits, right, even if they are both 9, we get only 1 at the 10th digit or the more significant digit, and something here. So whenever we add them, right, this is always less than what we previously had. And this is obvious because this is actually 9 times 10 plus 9, whereas this is just 9 plus 9, this one, right? So it is obvious that adding 2 digits always make them less if they are becoming 2 digits, right? So what can we do? Well, so I mean, what does this tell us? This tells us that if we do it at more significant digits, right, then that means we will get a less significant number, which is 1, at a more significant digit. However, if we do it on the right side, those are less significant because their 10 to the power whatever coefficient is less. So if we do it on the right, we will get the same number of digits and these will get smaller, but whatever the number present here, right, let's say 7 and 6, and then okay, it was like this, right? So these two get added, and then we have a very high number at the significant digit, at the more significant digit. However, if we added these two, we got a less significant digit, less number at more significant digit. So 7 5 is 12 6. So that is why always adding the least significant ones is better. So if we can get a double digit addition, right, like this or this, then we want to do it as at the rightmost possible place. However, if we cannot do it, then what? Then adding the two numbers. So let's take a number which has something like this. Now where do we add? Now here, notice that no matter which pair I add, I always get single digit. This gives 9 5 7 4 5 6 0 1. So since that is not possible, and now everything will only reduce our digits, we want to still do the same thing, have higher digit at the most significant bit. So if we were to do this, we will get 905. However, if we were to do this, we will get 905. Okay, this was a bad example. Let's do something like something like this. So if we were to add these two, we will get 915. But if we were to add these two, we will get 906. While this increased at this bit, this decreased, right? So just like previous one, here always adding to the most significant bit to increase them will help us get the better number, and it will also help that the numbers present here will get shifted to the left. So that is the solution, that if we can get double digits on addition, we want to prioritize that, and that on the rightmost side. But if that is not possible, we want to prioritize this single digit addition on the leftmost side. And what is the leftmost side? The first two digits. So that is the solution. Let me check if Codeforces is up yet. Okay, it's still not up. So I'm gonna have to code to explain the solution. It might be wrong slightly, but bear with it. So we have a string. Sorry. So we take input, and then let's say what is the chosen index. Let's call it index, and initialize it with 0, and go through everything, go through all the index of the string, get the first digit, which is this, right? So we are iterating on the string and getting the two digits, and if their sum is greater than 9, we will get two digits, right? Then that means we want to update index, but we don't want to break. Copilot is wrong here. we want to keep updating it because we want to take the rightmost one. And if this never happened, then we will have index set to 0, which is what we want. And now we can just construct our answer. So for integer I equals 0, first of all, we iterate up to before the index that we are adding. Then we get this thing, and we just say answer plus equals to string, and then so this is the same thing. So if we are adding index and index plus 1, we first of all add to our answer all the indices before index, then we add the index and index plus 1, convert it to a string, append to our answer, and then append the remaining ones, and then we just print answer. And to check if it is correct or not, let's copy this, and then we have this. Okay, what's happening here? Int string s c in s index if x plus y is greater than that. Let's just print index first of all to see what's happening. What is index? Index is 4, 0, 1, 2, 3, 4, 7 plus 5, 1, 0, 0. Oh, this is wrong. Oops. I didn't notice that it was I plus 1. So yeah, this was an error by Copilot. Sometimes Copilot ruins my day. So that was the solution. And now let's look at the problem C. So in this problem, we are at a level and there are n monsters in this level that appear at some time. Okay, so first monster appear at time k1, second at k2, third at k3, so on, nth at kn, and all of them are given in sorted order, and the health of that monster is h1, h2, h3, hn. Now the way we cast spell is, if we have not casted a spell at a time instant before this, let's say we are at 5th second and at 4th second we have not casted the spell, so the power of our spell would be 1. However, if we had casted and it was x, then the power of our spell can be x plus 1 or 1. We can decide whatever we want. So what we want to say is, and whenever we cast a spell, the cost, the mana expenditure is equals to the power of the spell. So whatever, if we have x plus 1 or 1, whatever is the power of the spell is the mana expenditure. Now we want to tell what is the minimum mana so that we can kill all of them, and to kill any monster or whatever they are, we want to cast a spell with power greater than equals to hi at the time instant they appear at, so at ki. So the reason I drew them in a number line is because it is much easier to understand it in number line. So let's see it again. So it was like this is 0, this is k1, this is k2, this is k3, and then we have kn. So let's say this guy had health 2. So if we want to defeat him, we have to cast a spell at first of all ki minus 1 instant, so that at the next instant we can cast a spell of power 2. Because if we want to cast a spell of power x, we need to cast spell at some point of time before it, such that we cast spell 1, 2, 3, 4, and then at exactly that time we cast x. So at time, if this was time t, we want to start casting at t minus x plus 1. So like here, if you want to cast spell at ki of power 2, we need to start casting at ki minus 2 plus 1, which is ki minus 1. So we cast 1 here and then 2 here, and we are able to defeat him. Okay, now for the next monster, let's say we need 2 again. So we cast 1 here and second here, and we defeat him. But let us say defeating this third monster requires 10, and if we want to defeat him, we need 10, but the space available in this much is less than 10. That means we have to be casting it from somewhere around here, right? So we have 1 here, 2 here, 3 here. So this gets overridden, right? Because this will obviously be greater than or equal to the required one. So it obviously gets overridden. 7, 8, 9, and then we cast a power of 10 here. And this keeps happening. And maybe at some ki, right? Let's say we require health equals to ki, then we will need to discard all of these and start casting from 0.1, 2, 3, so that we get ki. So if you re-visualize this, what you're getting is we are getting a lot of segments, right? So we have one segment here of length 2, or sorry, length 1 with 2 points. We got a segment here which was yellow, that's why I drew them in colors, and then we got a segment which is blue of length 9 or whatever, and then we had another segment. Let's ignore that segment for now because it kind of ruins the purpose. So now really this one got overshadowed, right? And if there was, let's say, another segment here, then the final segment would be the result of these two. So it would be like this. So we're just extracting out all the required segments, and then we are merging all those segments to know what is the actual time duration we need to cast spell. And for every final segment, we can just get its length. And if its length is, let's say, 5, then we expend how much mana? 1 plus 2 plus 3 plus 4 plus 5, right? At the final step, we want to expend 5 mana, and we start from 1. So it is just sum of first k natural numbers. So 5 times 6 by 2, which is 15. So this is what we want to do. First of all, get all the independent segments, then merge them, and then calculate this formula for every segment. Now, don't try to do this calculation while you are calculating these segments, because that's what I did and I got 4 WAs. I know why it happens. That is an exercise left to the reader. If you are trying to simplify the implementation, you can try why that would go wrong. But let's discuss the implementation. So we have n. Okay, let me see, is Codeforces back yet? Because if Codeforces is back, I can show. Nope, I'm gonna have to code it. Pain. Then we have vectors k and health. I take them in the input, and now first of all, let's form that range, right? So we iterate through every segment, every point, and r for it would be, or the right part would be just ki, right? Because we want it to end at ki, and it starts at r minus hi plus 1. So we just add that, then we will sort this because we want to do the merging. So I'm gonna do the merging here. So this is the initial segment that we have. This is an invalid segment, as you can see, since L is greater than R. Now we will iterate through every segment we have and merge them, and after merging them we will calculate what is the length of it, and then we will use this formula to add it to our answer. So let's initialize answer as well. and let's iterate through v and see if CL is greater than our previous R. That means what is happening is that this is a segment which is detached. So that means we can just add to our answer this and assign the new segment base. This is the case where the previous segment was like this and the new segment is this. So this is LR CL CR, and otherwise it would be something like this, LR CL CR. So I'm assigning the bigger of R and CR because it could also be like R is here. And in the end I would have not processed one of the segments, which is the last one, and then I just print the answer. So let's see. This is the question, right? I hope so. No, this is not. This is it. I remember the test cases of the problem which I bricked for so long. So yeah, this works. This was the implementation. Now let's look at problem D. Problem D. Okay. For problem D, I will have the implementation. I'll just have to do undo. Okay, whatever. First of all, let me explain it though. So in this problem, we have n, what was that? Right, n participants and their weight. Okay. So we have n participants. Let's use black color. And their weights are given. So their weights are A1, A2, A3, AN. What we want to do is we want to divide them into lightweight, middleweight, and heavyweight. And after dividing, so let's say the boundary is X and Y. So anything less than everyone less than weight X would go in the lightweight category. Anyone greater than equal to X and less than Y would go into the middleweight, and anyone greater than equal to Y will go in heavyweight. Now let's say there are X people here, Y here, Z here. What we want is we want X to be a power of 2, Y to be a power of 2, and Z to be a power of 2. And if they are not, what we can do is we can bring in additional participants. So let's say this was, let's say 4, this was 8, so these are power of 2, but this was 3. So we can bring one additional participant and make it 4, which is a power of 2. And doing so will give us cost of 1. We want to tell that what will be the minimum cost if we are free to select X and Y. So if we can freely select X and Y, right, we want that the additional participants we are adding to be minimum. So let's see how we can do this. Now here notice that the requirement is that X, Y, Z to be a power of 2 and n is less than equals to 2e5, right? So there is about 18 possible powers. So we can just brute force on the participants we will get in the lightweight category, which can be from 2 to the power 0 to 2 to the power 18. So X can be from here, Y can be similarly from this same range, and so can be Z, right? So we are already checking that, okay, if X was this, Y was this, and Z was this. And why we are able to do this? Because these discrete values are very less. This is log cube n, right? So we will check every possible arrangement of powers. Now, okay, we can hypothetically go beyond this, but in that case, it will never be optimal because we are just adding too many extra people. We will have a better solution with less people. Because 2 to the power 18 is like a lot. It is a lot more than 2e5. Much more than twice, so it will always be optimal. Okay, now what can we do here? So now that we have selected x, y, z, we want to find an x such that we get less than equals to, okay, wait, I select, okay, let's call it a and b. This was getting confusing. So I want to select such a such that the total number of people I'm getting from this array is less than equals to x. Because let's say it was like this, right? 1, 2, 3, and then 2. These were the weights. If I selected 2 as a, right? If a was equals to 2, then that would mean that wait a minute, just a minute, I'll be right back. Pause. How do I pause? Okay, I'm back. So we were here, right? So if I selected a to be 2, then I will get 3 people here, and right, I will get 3 people. And if you wanted x to be equals to 2, then we won't be able to get it because we will get all these 3 people. So if I want x to be equals to 2, I will have to select 8 as 1, and we will get 0 people from that original set or array, whatever it is. So that is why we have to carefully choose a such that we get less than equals to x people, and similarly we carefully choose b such that we get less than equals to y people, and then we want to ensure that the remaining people, which will be in z or high heavyweight set, are less than equals to z, and after that we just see the remaining people in x, y, and z. That is what will be the requirement for this particular xyz value, and we just take the minimum of all the possibilities. So if we go here, let me just keep undoing, so I eventually reach the solution. This is slightly bigger and tedious to code, that is why I'm preferring to just undo. Okay, so we take input, wait, now this is C. Okay, so we take input and we sort it. The reason we are sorting it is because what we will do is we will store, so if it was like this, right, we will store their counts, so it is 3, 2, and then 2, and then we'll store its prefix array, which is 357, so that we can very efficiently find how many people we will be getting in the current set. So that's what I'm doing here. I'm counting the number of equal values, pushing it into V, and then updating I, and then creating a prefix sum out of that, and storing its size in M. Mx maximum is 20. So I tried with 17, and 17 would work if n was less than equals to 25, but n was less than equals to 25. I got a penalty for no reason, so I just tried 20. Who cares? Initially answer is infinity. I'm storing power of 2 so that I don't have to recalculate them every time. Now x from 0 to mx, y 0 to mx again, z 0 to mx again. We are getting the count, which is the actual length size of the set we want. Now I'm finding the first value in the prefix sum which is greater than cx, which is the required number of people in the first set, and if it is 0, then so basically here, like in this case, if you want 2 people at max, right, then upper bound will give me 0, so I don't even want to take anyone from here, so answer would be 0. Otherwise it would be vi minus 1. And similarly I do an upper bound, but this time for not just cy, but I'm adding lw as well, which is the people I've already added in lightweight, and similarly assign middleweight, and heavyweight is this much, the total number minus how much have been assigned. If it is greater than cz, of course we have overshot and we don't want to continue, so we continue and then I calculate the value. So these were the target values, these were the values I have gotten. The difference is the current expenditure or current addition of people, and I just take the minimum of all the possibilities. I print that out, and this works. So that was the solutions. I coded ABC live. So if you like that more, tell me. I will try to do it more, but not for overly complicated solutions like these, because that takes a lot of time. And that being said, the contest seems to have ended and will obviously be unrated. Imagine if it is rated. So yeah, if you look at my submissions, so much problems due to oversimplification, and then that one stupid answer. And here as well, the wrong answer on test 2 here, it is because instead of writing greater than 9 in that one if statement, I wrote greater than 0. I don't know where it is, but yeah, that was the problem. But unfortunately, this will be unrated. So with all that said, that was the solutions. Hope you like. Leave a like, subscribe, and join my Discord once again for more discussions and random time waste, because let's be real, you don't have anything better to do, just like me. And bye.